previously we talked about the movement of air into and out of your lungs. And this was based on the differences of pressure between atmospheric pressure and intrapulmonary pressure. At sea level, we know that the atmospheric pressure was 760 millimeters of mercury. And in order for you to inhale, the intrapulmonary pressure had to be less than that. Okay, so if our sea level was at 760, intrapulmonary had to be at least 759 in order for the air to move down its pressure gradient. This is associated with the Boyle's law. Now let's take a look at movement of specific gases within this. Okay, this is going to be a major part of how oxygen is going to move from your alveolus in your lungs into the blood, and carbon dioxide from your blood into the alveolus, and at the systemic exchange, how oxygen leaves the blood and goes to the cell, while carbon dioxide leaves the cell area and goes into the blood. So, and this is all going to be based on partial pressures. So let's look at this a little bit more detail on here. So we said that atmospheric pressure at sea level is 760 millimeters of mercury. So let me go back to, let me do this in black on this one just so we can keep it consistent. So 760 millimeters of mercury. This is at sea level. Okay. And so if you climb a mountain, this pressure changes. If you go underwater, this also will change these there. But for what we want to do here, let's just stay at least sea level, and it's a little bit easier to focus in on. So Dalton, we said we were going to talk about Dalton's law. Okay, so let's define what Dalton's law is before we get into all of this. So Dalton's law, and what Dalton's law basically says is your total pressure of a mixture of gases is equal to the sum of individual partial pressures, is equal to the sum of individual partial pressures. Okay, so what does all of that mean? Okay, so the total pressure of a mixture of gases. Let's start with that definition. The total mixture. So the air that we breathe is a mixture of gases. Nitrogen, oxygen, carbon dioxide, water vapor, all of those. The pressures of individual, the sum of the pressures of the individual gases equals 760 millimeters of mercury. Okay? So when we're looking at this, let's go down a little bit and let's figure out how do we calculate what the partial pressure of the individual gas is. Okay? So first we have to know what the total pressure is, and at sea level we know that that is 760 millimeters of mercury. Okay, so this is total pressure, and that is multiplied by the percentage of gas within the total mixture. So what percentage of oxygen is the air? You've probably heard that this is 21%. A little bit more specific, 20.9. Okay, so 20.9%, and this is oxygen. So 20.9%, 21% of the air we breathe is oxygen. Okay? So you multiply 760 times the 20.9%, that equals 159 millimeters of mercury. Okay? The next one we're looking at, 760. Let's do nitrogen since that's the primary gas in it. And that is 78.6. And this is nitrogen. And then that equals 597 millimeters of mercury. Okay. Then we have carbon dioxide, 760. Carbon dioxide is 0.044%. That's CO2. And that's going to give you 0.3 millimeters of mercury. We have water vapor. Water vapor, let me get that, 0.46%. That's water vapor. And that gives you 3.5 millimeters of mercury. Okay, so now what all this is the 159 plus 597 plus 0.3 plus 3.5, all of that has to be 760 millimeters of mercury. Okay, so the partial pressure of oxygen is 159 millimeters of mercury. Partial pressure of nitrogen is 597. Okay, so that's what we're looking at on this. So when we're talking about movement of gases, let's say from the alveoli into your bloodstream or between your cells in the systemic system, from your cells into the bloodstream, either direction on this one, we're looking at the movement of gases based on its pressure gradients. Not the total pressure, not the 760, but the individual pressure gradient of the individual gas. So let's look at oxygen very briefly. In the next video, we'll go into a little bit more detail on this one. When you are breathing in fresh air, you have 21% oxygen, and I'll put an asterisk on that because we're going to change it, but we have 21% oxygen coming into your lungs, okay? You have less oxygen, or let's do the partial pressure. So for 21% oxygen in the air, that's a partial pressure of 159. Okay, and again, put an asterisk on that because we're going to change it up in the next video. So let's say it's 159. In your blood that's getting rid of the carbon dioxide, the partial pressure of oxygen will be less than 159. So oxygen is going to be moving from the alveolus into the blood. So just like we did diffusion, high concentration gradient to low concentration. We did it with the Boyle's law, movement of gases based on pressure gradients. Here, Dalton's law is the movement of individual gases, okay, based on its pressure gradients. So if you have oxygen in its both places, one area's got a higher partial pressure and another a lower, the gases will move from an area of a higher pressure gradient to an area of a low pressure gradient until they equalize. So high pressure, low pressure, gases move this direction until they balance out and then they equal. Okay, so this is the whole intent on learning this. Now partial pressures, and if you look at your book, the partial pressures of gases are abbreviated a little different. So partial pressure, it always starts with the letter P, and then you will see the symbol for the gas. So oxygen, partial pressure of oxygen would be this. And we had that as at what 195, 159. So that it'd be 159 millimeters of mercury. Then we have partial pressure of nitrogen. Partial pressure of nitrogen, 597. I don't have these memorized. 597 equals 597. Partial pressure of CO2, that's going to be 0.3. Partial pressure of H2O, that's going to be 3.5, not 35. And that totals up to 760 millimeters of mercury. Okay? So when we talk about in this next video on which direction does oxygen move, or which direction does carbon dioxide move, we are going to be basing it on the partial pressures of that individual gas. Before this, we talked about air as a whole. Okay, we talked about air moving from the atmosphere into our lungs. Now we're looking at the individual gases on the direction that gases flow. Okay, so that's going to be next up. We are going to be changing, just a little heads up, because the partial pressure of oxygen in the alveolus, so when you breathe in air, it's not going to be 159. It's going to be a little bit less than that. And this has got a lot to do with, well, let's just wait till the next video and we'll talk about that one. So until then, stay tuned.